Okay, so we have this figure constructed of 21 rods connected at their ends. And all the rods are exactly length 1. And we want to prove that angle A is greater than 90 degrees. We know that there are 360 degrees around a circle. And there are 4 angles of 60 degrees each in this circle, plus the 2 unknown angles A and B. So we have A plus B plus 4 times 60 equals 360 degrees. This simplifies to A is equal to 120 degrees minus B. So to prove that A is greater than 90 degrees, we need only to prove that B is less than 30 degrees. Angle B is part of a triangle with sides of length 1, 2, and 2. Let's compare this to a 30-degree triangle. Take an equilateral triangle with sides of length 2. We know that it has 3 60-degree angles. Now draw a vertical line down the center of it, dividing it into 2 30, 60, 90-degree right triangles of height h and base 1. Pythagoras tells us that h is equal to the square root of 2 squared minus 1 squared. That's equal to the square root of 3. Let's examine the triangle on the right by itself and compare it to our 1, 2, 2 triangle with angle B. We'll turn the 2 triangles on their side and line their angles up for comparison. And let's zoom in for closer comparison. Now it is easy to show that angle B is less than 30 degrees. This leg of the 30-degree triangle is standing perpendicular to the base, straight up. And this leg of the red 1, 2, 2 triangle is tilted. I'm sure your mother has told you to stand up straight and tall. So this answers part 1, proving that angle A is greater than 90 degrees. We have done that by showing that angle B is less than 30 degrees. Now for part 2, we must find the value of angle B. For that, we need to know some trigonometry. Let's review the primary trigonometric functions: sine, cosine, and tangent. The right triangle below has hypotenuse h and angle alpha. Sine of alpha is equal to opposite divided by hypotenuse, equals O over h. Cosine of alpha is equal to the adjacent side over the hypotenuse, A over h. Tangent of alpha is equal to opposite divided by adjacent, O divided by A. SOHCAHTOA is a handy memory aid. These trigonometric relations apply to right triangles. Our 1, 2, 2 triangle is not a right triangle. But we can split it into 2 right triangles of angle B divided by 2 by drawing a line through the center. We know that the sine of B divided by 2 is equal to opposite divided by hypotenuse. In this case is equal to 1/2 divided by 2 is equal to 1/4. So we need to find the angle B divided by 2 whose sine is 1/4. This is called the arcsine of 1/4. You can look it up in a trig table or use a scientific calculator to find it. So to answer part 2 of Renaissance puzzle number 47, B divided by 2 is equal to the arcsine of 1/4, which equals approximately 14.4775. So b then is equal to 2 times the arcsine of 1/4, which equals approximately 28.96. Recall that angle A is equal to 120 degrees minus angle B, which is equal to approximately 120 degrees minus 28.96 degrees. So angle A equals approximately 91.04 degrees. Quod erat demonstrandum, Latin for which was to be demonstrated. And special thanks to Jeffrey Merrow for unintentionally contributing this interesting puzzle.